As introduction about the geometry tab in the software, we're gonna find that there is a lot of techniques for start drawing our geometry in the software, and it has a lot of commands which facilitate this task. So we can find that we have point and line, arc, circle, polyline, rectangular, and we have many of AutoCAD or like application like offset and extend and other soft and align, many application of AutoCAD, so you can start to draw easily in the Midas GTS NX software. But as well, I'm gonna show how to use AutoCAD and then export from AutoCAD to GTS NX, where you can complete your model. Now we have to modify to create faces and solid. So most of our problem, it's gonna be like some elements are 2D element and 3D element. So to modify or to improve the 1D element, like some shape like this, we have to create face which indicate 2D element if we are dealing with 2D problem, or we have to extrude this face to 3D element if we are going to deal with 3D problem. So Midas GTS NX provides a lot of like a very rigorous technique to extrude and to create our face and solid easily. So you can find cylinder, cone, box, wedge, sphere, plate, chamfer, offset, and as well you can like extrude these surfaces. Let's say if we want to create very complicated solids, like as we see here that we have this kind of cube with a hole inside or with this ball, so we can use something like Boolean operation like fuse and cut and common, as we're gonna see later, to create our solid. And we can use operations like divide and protrude and transfer, so we can complete our geometry easily. So as we see, and as we're gonna see more later, that GTS NX has a very good interface. You can use it to create your first initial model geometry very rigorously. After you finish your geometry, as I said before, that we can use AutoCAD, so we can import or export the model to GTS NX. And it says that Midas has different softwares, not just GTS NX. It has Midas Gen and Midas Civil and SolidWorks. And what's amazing about these softwares, they are all connected together, so you can import from Midas Gen, for example, your structure, and you can import it with its load to GTS NX and complete your real model there. After finishing the geometry, we go to the step of creating mesh. There is a lot of techniques. As I said, if we have like a wall, some wall like this, we divide our geometry into small elements, and we calculate the straining action and the stresses and strains at the nodes, at these nodes. So the software provide a very rigorous and very sophisticated technique, which we could use to create our models very fast and very accurate. and the software provide a technique for meshing in 1D and 2D and 3D, and even we can create interface, pile, and other structure elements, as we're gonna see in the lecture later. Here the Midas has different techniques for meshing, like here these are tetrahedral element and this is a hexahedral element. So the software gives you the option to choose what is the shape of element. So you can divide all your element to like tetrahedral or hexahedral, but the software also give you like a hybrid measure, so it can include between the tetrahedral and hexahedral, so you can get the very sophisticated mesh elements, which facilitates the solution and doesn't include any computational errors. Then you can include auto connect between faces and make mesh check to check that your meshing is good or not, and include the quality of your meshing, as we're gonna check this again later. Loading, the library of Midas has a lot of kind of loading. We can divide it into static and dynamic loading. So in static loading you can include self weight and concentrated load, moment load, prescribed displacement and pressure load, water pressure and beam linear load, beam element load, temperature, pre-stressed force, and even combined loads. In dynamic, and as I mentioned in the advertisement, that the Midas has very wide library for dynamic, so we can like do any kind of dynamic analysis very easily, because it has the response spectrum, ground acceleration, time history, static loads, dynamic nodal, dynamic surface load, and real. Even we can include railway dynamic load, as we're gonna take like a problem or uh, a lecture about this later. So we see that Midas in loading has very wide library for loading. Boundary condition, as we see that we have to define the domain of our problem, and we have to define this domain in the two direction, like we in the 2D, for example, we have to create the domain here and the domain here, and to prevent the lateral displacement we allow with vertical displacement, and at the end we prevent both vertical and lateral displacement. We will see later that, and even we include the dynamic boundary condition, like the elastic boundary condition and the viscous boundary condition and the damper consideration in free ground. We will see a lot of these techniques later. And even Midas has like this technique to include the automatic boundary condition, so it's very smart to include this. And about slope stability, we can create slope stability with different techniques, so we have to put the boundary condition like the slip circular surface or the polygonal. After we are done with this techniques, we come up to results. So the results here, we can have wide results view, like vector diagrams and flow net and time history graph, 2D results wizard. We will see that here we can create seepage flow, and here we can take this isoblan, so we can see inside the structure. We will see all this later, and we can use probe, like, so we can read any reading at any node. And as we see, there is a lot of techniques for viewing the results, and we can extract the results and we can export it to Excel, for example, and we can create like auto report. We choose all parameters or all results we need to show in a report, and Midas give you like 3D report. So it's very amazing to have a calculation sheet from the software. Tunnels is one of the important like in now we are going to talk about what problems we can consider in the software. And as we know that tunnels is one of the main important geotechnical structure, and they are very complicated. So in our analysis, we're gonna study different kind of tunnels, and we're gonna model very complicated one, so we can understand um, how we can like use the most benefit from our structure from our software. We can as well include like as I said, route tunnel, railway, and steel pipe roof. Here we can include a strength reduction method for slope stability. We can create slope stability here for this structure using strength reduction method. We are going to talk about the strength reduction method in details in one of the lecture related to slope stability, and we will discuss the difference between strength reduction method for finite element and the limit equilibrium analysis using slide software. As well, we can do seepage analysis. So we study the quantity of water escaped in the dam, and we study the flow net, and we can evaluate even the slope reinforcement for slope stability, like nailing, rod plot, stabilized pile, and a lot of techniques. Here we can see we can create foundations, like this is an abutment for a bridge, and this is a regular building, and this is a pile foundation. So we can use Midas GTS and X for the analysis of different foundation structure. Now we can discuss about using like embankment and soft soil. So we are going to discuss this later in the lecture related to creating embankment and studying the consolidation problem.